Hello everyone. Today we are going to discuss about how to measure mass and weight of an object. Before that, we should know what is the difference between mass and weight. Actually, mass is the property of an object. Mass is the amount of matter present in it. And you have to remember that mass is same everywhere. Whether you take that object to moon or any other planets, the mass is same everywhere. But in case of weight, it is different from place to place, because weight depends on the gravity. If we weigh on Earth and the same object can be weighed on moon, the weight will be different. Now I will explain you how to measure the weight of an object, or mass. How can we measure mass of an object? The mass of an object can be measured with the help of beam balance, right? But the weight of an object can be measured with the help of a spring balance. Here you see, this is a spring balance, and this spring balance works on the principle of Hooke's law, right? Now you see, I am showing you by focusing that this is our spring balance, and you see there are calibrated scale in two positions. One is in gram, you see 0, 50, 100, 150, 200 and 250, and it is in Newton, that is 0, 0.5, 1, that is 5, 2 and 2.5, right? This is 1.5, 2, 2.5, right? Now I will show you how to measure the weight of an object. We already told you that mass can be measured with the help of beam balance, but weight can be measured with the help of spring balance, and it works on the principle of Hooke's law, right? Now we will show you how to measure the mass of weight of an object. Before that, you have to find the least count. You have to find the least count. Here you see, first you find what is the division between them, right? Here you see there are 0 to 0.5. How many divisions? 1, 2, 3, 4 and 5 divisions, right? 5 divisions is 0.5 Newton, right? That means you have to find 1 division, right? That is, first of all, you have to find the least count. Now how to find the least count is, here you see, this is our spring balance, and with the help of spring balance we can measure the weight of an object. First of all, we will find the least count. How to find least count? I already told you that here you see that from 0 to 0.5 there are 5 divisions, 1, 2, 3, 4, 5, right? That means 5 division is equal to 0.5 Newton, 0.5 Newton, and Newton is the SI unit of weight, right? And the CGS unit of weight is dyne, right? Now you see, 5 division is equal to 0.5 Newton, therefore 1 division is equal to 0.5 by 5 Newton, and that is we are getting 0.1 Newton. right? That means one division is equal to 0.1 Newton, and that is the least count. Least count is 0.1 Newton. 0.1 Newton in this spring balance. Now we shall try to measure the weight of an object with this spring balance. Let us find out how we can find out. Here you see, this is an object and we want to measure the weight of this object, right? Let us see, we want to measure this weight of this object, right? Let us see what is the weight. You see, this, whenever we put this on the hook, the spring extends because the earth is attracting this object towards its center of earth, towards the center. Now if we hang it, you see the spring stretches, right? It is greater than that, therefore you can change this object to other object, right? Now you see we are taking other object right now. Now let us take another object and we will try to measure the weight of this object. You see how to measure the weight of this object. You just hang on it and you see the spring is extending, right? Now you take the reading. You see here, what is the reading? The reading is 0.1, 0.2, 0.3, 0.4. That means the weight of this object is 0.4 Newton, right? Therefore, the weight of this object is 0.4 Newton, and you can write it here as weight of this object. Weight of this object. Weight of this object we get 0.4 Newton. Let us see once again. Here you see, if we want to measure the weight of this object, we are getting 0.4 Newton. Right, here you see the indicator, it is 0.1, that are 4 division, 1, 2, 3, 4. 4 into 0.1, that is 0.4 Newton. Therefore, the weight of this object is 0.4 Newton. Now I will measure the weight of another object, that is this one, and let us see what is the weight of this object. You see here, there are three divisions. You see here, 1, 2, 3. Therefore, the weight of this object is 0.3 Newton, and weight of this object is 0.3 Newton, right? Therefore, we can write that the weight of this object is 0.3 Newton. In this way, you can measure any object, right? In this way, you can measure any object with the help of this spring balance. And I already told you that the spring balance works on the principle of Hooke's law, right? Now we got the difference between mass and weight. Mass is the property of matter. It is the amount of matter present in that object, that is mass. And it is same everywhere. If you take this object to moon or any other planet, the mass will be same. But the weight differs from place to place, right? If we take this object to moon, the weight will be different the weight will be different from that of Earth or any other planet, because weight depends on the gravity of a planet. For example, in our case, in Earth, if we measure the weight of an object, there is a formula: weight is equal to mg. Weight is equal to mass into g, that is acceleration due to gravity. right? That means if we know the weight, we can find out the mass with the help of this formula. For example, weight is equal to m into g. We want to find the mass of this object. If we know the weight, we can find the mass also. That means mass is equal to weight by w by z. If we divide weight by gravity, then we can find the mass also. But today's spring balance have the calculation of mass also. You see here, that means with the help of this scale we can find the mass also here, right? Here you see this is 0 gram, 50, 100, 150, 200, 250. That means 0 to 50 there are how many divisions? 1, 2, 3, 4, 5. Right? 5 divisions is 50 gram, therefore 1 division is equal to 10 gram. Right? That is 1 division is 10 gram. Right? Now you can find the mass of this object also with the help of this spring balance. Let us see how we are finding. You see here, if you want to find the mass of this object, what is the mass of this object? And what is the unit of mass? The unit of mass in SI system is kilogram, and the unit of mass in CS system is gram, right? Now we will find the weight of this mass of this object with the help of this spring balance, because it is calibrated in gram also, and this is the weight and this is the mass. Let us find out. Here you see how many divisions? 1, 2, 3, 4. There are 4 divisions, right? And we are getting 10, 20, 30, 40 gram. That means the mass of this object is 40 gram, right? The mass of this object is 40 gram. Now, if we try to measure the mass of this object, let us find what we are getting. Let us see. Here you see. Here you see. There are 3 divisions, 10, 20, 30 gram. The mass of this object is 30 gram. What we find that mass and weight are related with each other, and we find the formula also, that is weight of an object is equal to mass of the object and acceleration due to gravity, that is g. That is force weight is equal to mass into acceleration due to gravity. That means mass and weight are interrelated. That's why we can find the weight of the object with the help of spring balance. If we want to measure the mass of an object, we have to take the beam balance, right? With the help of beam balance, we can find the mass of an object. But with the help of spring balance also, we can find the mass of the object in this way, because it is calibrated in 2 scales. One is for mass and one is for weight. But generally, we use this spring balance to measure the weight of an object. And if you want to measure the weight, if you want to measure the mass of an object, you have to use beam balance. That's why I say that beam balance are used to measure mass, but spring balance is used to measure weight. Even we can measure the mass of an object also with this spring balance, because there are 2 scales, one is for weight and another one is for mass, right? But generally we use this spring balance to measure weight of an object. Now what is weight? Weight is the force of our earth to which it attracts all objects towards its center. That is the force, and that is the weight. And weight is a vector quantity because it has a magnitude and direction also. And mass is a scalar quantity because mass has only magnitude but no direction. And the mass is constant everywhere, but the weight differs from place to place due to this factor, that is g factor, that is acceleration due to gravity. Because the acceleration due to gravity is different from one planet to other, therefore the weight will differ from one planet to that of others. But in case of mass is the property of an object. That's why mass is same everywhere. Wherever you take that object, the mass will be same, but weight differs from place to place. Now what we find at the end, that with the help of spring balance we can measure the weight of an object in this way. Now let us try to find these both the objects, weight of these both the objects. How can you find? Let us find in this way, that let us take this one and weigh it and hang this object also, and let's see what the weight is. Here see, here you can find the reading, right? Here you see one division is 0.1, that is 0.5, 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. You see, it is 1.9 Newton. That means the weight of this object is 1.9 Newton, right? Therefore, we can write the weight of both the object is 1.9 Newton. Therefore, weight of the both object is 1.9 Newton. Right? Let us, or in this way, we can measure any object with the help of this spring balance. Right? First of all, we attach the object with this one, and it extends. The spring extends, and we already told you that the spring balance works in the principle of Hooke's law, right? Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video. We already told you that we have two sections in our channel. One is for scientific experiments and the other one is for CBSE Educare, that means for science and mathematics from class 6 to class 12. Later on, we will discuss all the chapters of CBSE one by one, not only all the chapters, but all the questions one by one for you. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.